Hi friends, good afternoon. In the last session, we focused on methods, constructors, or types of constructors. We have defined a default constructor and a parameterized constructors. We have also discussed the rules of having constructors in Java. Next, we are continuing with respect to some instance variables, classes, local variables concept. We are discussing this code. We consider this class, for example, class sample, having two instance variables int x, y. X and y are instance variables of class sample. Instance variables of class sample. Define one method void f, which takes two integer parameters, int x into y. Then, having these assignment statements, x is equal to x star 2, x is equal to x star 2, and y is equal to y star 5. This is the method definition. Method is closed here. Next, coming to a method, say void. This is visible. The method say this prints the content of an x and y. Void p. Let us display the contents of x and y. X is equal to x and y is equal to y. I have written the code in a single line for clarity. Okay. Then consider the classes A. Inside this, a main method is defined. Static public void main string arguments. Assume the class name is sample. We are constructing the object here. Sample s is equal to new sample. Then assigning the instance variables explicitly through the object of the class. Because x and y are public instance variables, right? This is same as public int x comma y. Now s dot x is equal to 10. Let me write it here. The same line. S dot x is equal to 10 and s dot y is equal to 20. Then we are calling a method s dot p to display the contents of x and y. Then the method f is called s dot f of 15 comma 25. Then we do want to print the contents of x and y by calling s dot p. A very simple program in which the class sample consists of two instance variables, say x and y. The instance variables x and y are initialized explicitly inside the main method as s dot x is equal to 10, s dot y is equal to 2. Printing s dot p, first we are printing the values of x and y. So here what is the expected value of x and y? X is equal to p, we have printed just the values of x and y.
1020.
And x is equal to 10, y is equal to 20. And have a look into this method called s dot f of 15 comma 25. F is just the method. We define void f into x comma into y. Now f of 15 comma 25, 15 and 25 are actual parameters. Actual parameters can be the values directly. We are provided the values directly. So 15 comma 25 has the two integer values. Actual parameters are passed to the formal parameters here. X is equal to 15 and y is equal to 25. Now what happens? The variable here x receives 15, y receives 25. Now writing the statement x is equal to x star 2, y is equal to y star 2. The variables x and y are updated here. After the method call, we are printing the values of the same x and y by calling the method s dot b. What is the output of this method call? X is equal to actual parameters.
1020.
X is equal to what? 20. Here x is 15, y is 25, received in the variables x and y. And updating x is equal to x star 2. That means x becomes 15 into 2, 30. Y becomes say
125.
25. After the method call, we are printing the values of x and y. What will be the output?
Thirty, 125, sir.
Okay.
1020, sir.
10 to 10, 20, okay, 30, 125. Which one is right? Give the justification for 10, 20.
In C++, in this case, we use this point to differentiate between the local parameters and instance variables, sir.
Yeah, very good. You are exactly right. And C++, you may have used right a pointer. That is this pointer. This is a pointer. It is automatically passed right from the or whenever the method is called. So since this is a pointer, you might have studied in C language. There is some special operator called pointer to member access operator, minus greater than operator. So, to resolve the name collisions in the member functions or function call, you need to use this pointer, this minus greater than operator. Then you need to define the variable of the class. To avoid or to resolve the name collision. For example, here x and y are perfectly instance variables, no problem. Here, same x and y are declared. Already, right, we have discussed that in the scope, right, you cannot declare the same variable. For example, int x comma y, this is in the outer scope. Then in the inner scope, right, you cannot redefine the same variable that you have already declared in the outer scope. That is not possible. But here there is no concept of scope. Here this is instance variables. But here this is a local variable or formal parameter list. Instance variables and the formal parameters may have the same name, perfectly valid. So here the actual parameters 10 and 20 are being received in the local parameters or formal parameters x and y. So x receives here 15 and y receives the value 25. Having x is equal to x into 2 means wherever you are using the variable x, the last class I have said that wherever you are using the instance variables inside the method, there that instance variable or variables are referred by the invoking object. Here clearly the invoking object is s because s dot f. S is the caller of a method f. But here the local variable x and y, that is formal parameter, and instance variables x and y are the same. In that stage, right, what happens means the local variable hides the scope of instance variables. Local variable hides the scope of instance variable. So this case, this x is pointed by this local x, and this y is pointed by this local y. So wherever x and y are mentioned directly, right? Those are referred by this formal parameters. So formal parameters, you know clearly, can have the scope only within this opening and closing curly braces. When you come out of this method definition, local variables will not have a scope. So x is equal to 30, y is equal to 125 can have the scope only within this opening and closing curly braces. Longevity. After this control comes out of f means then the local variable scope is over, then the object S has already been initialized as 10 and 20. So same initialization is taken is 10 and 20. And the concept is how the instance variables are hidden inside the method. When the instance variable and local variable name is the same, local variable takes high precedence to hide the actual scope of instance variable. That stage, you cannot directly refer the instance variables inside this method definition. Understand or not? So to resolve this RTI today means we need to use the concept of this pointer in Java. Actually, this is not a pointer, but this is directly possible. Whenever the object is called a method, this is directly possible. So using this, you can resolve this name collision in Java. Java C access editor Java. Running the code Java classes 8. So before and after the method call, we have the same results. X is equal to 10, Y is equal to 20. This is how means because the local instance where local variable hides the actual scope of instance variables. To resolve this, as we studied in C++, this is the keyword to be used. This automatically refers to invoking object. Here there is no pointer concept. So the pointer to member access operator is normally replaced by the dot operator. Why means this is the object name. Object name dot, this refers a current object. Current object dot the instance variable. Hence this dot instance variable should be used to resolve the scope of instance variable. The same code here, for example, class sample int xy, void f int xy. This dot x is equal to this dot x star 2. This dot y is equal to this dot y star 5. So clearly what happens, this dot x means who is the caller, corresponding caller, right? The object is referred by object, right? This refers the invoking object. So in this case, right, you will get the expected result as 15 into something, some operation we have provided. 15 into 2 and 25 into 5. So the usage is this dot x, that you should remember. This is a keyword supported in Java. This refers to invoking object. Since this is an object, to access the corresponding number, you need to use the dot operator. This dot instance variable. So this dot x means this dot x, this x is referred by this x. And this dot y or this dot y, this is referred by invoking object y. Output is 20 and 100. Okay, 10, 20, 15, 25. What happened? 15 into 2, right? X is 20, Y is 100. How can you justify the output? Invoking object is here yes. S dot x is set to 10 and s dot y is set to 20. S dot x means the value. 10 is taken, here the value 20 is taken. In case if you want to consider a value of 15 and 25 means here this dot x, this should be removed, for example. No confusions in this case. These two versions are okay. This dot x is equal to here, even if you write x, here write y. In this case, what will happen is this x is pointed by the actual parameter, formal parameter. Formal parameter receives the value 15. 15 into 2, 30. Here, this 25 is received in a variable y. 5 into 25, 125. In this case, he expected the result. 30 and 100. 30 and 100, is it? So yes, sorry, and y. Let us recompile the code. Thirty and 120. Okay. Purpose of having a keyword is this just to resolve the name collision with respect to local variables and instance variables of the class. Usages, don't forget this, then dot operator. After that, you can specify the corresponding instance variable of the class. And we are moving on to the next one. Method overloading. Method overloading, this is same as function overloading in C++. It has seen function overloading concept. Two functions are said to be overloaded. If and only if the two functions should have the same name. Two functions should have the same name. Then they can differ in number of parameters, type of parameters, or they may vary both in number and a type of parameters. It's not a new concept to you, function overloading. Already we are discussing C++ language. So let me explain directly through some examples. Void f. So consider this version.
So what about order of parameters?
Pardon? Not get you.
Order of parameters. Will the order of parameters also do?
Order. Order is also important. Int comma int. Here, for example, float comma float or float comma int. Order is important. So they should differ in the number of parameter type, right? When you say the type, right, the order comes automatically. Here, for example, int. Another version is float. Type is here int. Here type is float. Or int comma float. Second one, float comma int. So type and type means order comes automatically. Are both the number and the type. Count on the number of parameters and the corresponding type of parameters. Considering this, these two versions, here version f, right, it takes 0 parameter. Here the integer version, integer parameter, right, it takes only 1. So 0 and 1 parameters. The version, right, f is completely different from the second version f, because here the versions are differing in number of parameters, 0 parameter, 1 parameter. Function name is same. So these two versions are said to be overloaded. Second one, having one parameter, having two parameters. Count is 2. Here count is 1. So count, right, 1 and 2 are differing. Method name, function name is same. So these two versions are said to be overloaded. Third one, count is 1. Here also count is 1. One parameter, one parameter. But their type, data type is different. Here integer 1. Here a floating point 1. Since the type is different one, these two parameters are said to be overloaded. But to call the integer version, you need to pass the integer value. But to call the floating point, you need to pass the floating point value. Next one, void C. First version takes 2 parameters, second version takes 2 parameters, so 2 and 2. When the number of parameters is the same, then there should be a distinction in their type of parameters. Type is here integer comma integer. Here, for example, float comma integer. So clearly, these two versions are said to be overloaded. In case based on the return type, right, you cannot distinguish. For example, here void compute. Here float compute. Compute, same thing. Number of parameters, here 0, here 0. But the type signature is completely different. What is a type signature in Java? Type signature means return type, method name, parameter list. Return type, method name, parameter list. So the type signature is completely different. But the using the return type alone, you cannot conclude the necessary condition for method overload. So void and float, right? Of course, different types. If you want to call some object name dot compute semicolon, this version is called, of course. Some float x is equal to object name dot compute. This version is called, of course, right? But here return type is void, the return type is float. In this case, we cannot conclude method overloading only based on the return type. That is an insufficient one. Return type alone is insufficient to decide the method overloading. The same concept is supported in C++. So to have two methods or multiple methods to be overloaded, first condition, all of those methods must have the same name. Second condition, their formal parameters should vary in any of these three possibilities. Number of parameters, type of parameters, or in both number and the type of parameters, there must be a distinction. How the overloaded methods are going to be executed, right? Execution. Same as C++. Roots. During the method call, right, compiler tries to check if there is an exact match between the actual and the formal parameters. Say, consider this version. First one, object name dot f, no parameter. Here f, right, no parameter. So there is a match between the method call and the corresponding method definition. So simply object name dot f, zero parameter, invokes this version. Similarly, object name dot some f of 100 means this integer version will be called, right? So first the compiler tries to check if there is an exact match between the actual and the formal parameters. This is the first conditional check. If there is an exact match between the actual and the formal parameters, then the right version is going to be called. Otherwise, if rule number 1 fails, compiler tries to apply the automatic type promotions in Java. You know that basically by short, then cap, and corresponding literal numerical constants or literal constant, right? Those are converted to one integer data type. First two. Then second, if one operand is int and another operand is long, that means integer may be type promoted to long. And at the same time, integer may be type promoted to other than long. What are the compatible types? Integer is compatible with the no idea. Integer is compatible with
long float double.
what is the very good long float double, because integer occupies 4 bytes. Then float one long, right? Byte short int long 1248 long can be converted. 5 means 5L possible. 5 means 5.0 F float is possible. Then 5 is converted to 5.0 as a double possible. Literal byte short int long. Byte short cap, that's what, right? First they are converted to int, then the integer may be promoted to long float double, character also promoted to int, then that int further may be type promoted to long float double. So only two rules we try to know. This is the automatic type promotion rules from actual parameters to formal parameters. Another one.
So literals can be converted into any data type.
Literal.
Literals are type compatible with any data type.
literal, that's what, first integer, then integer is further type promoter to long float double, but literal to Boolean not possible. So only numeric types, character and literal to a numeric types, integer or floating point types. That is only automatic type promotion.
Thank you.
In case if rule number 1 fails, this automatic type promotion rules are to be checked. If it is possible, that can be automatically taken. If rule number 2 fails, like literal version is there, a character version is there, assuming that a method call is in a character version, method definition is in a Boolean version, character to Boolean, incompatible data types, incompatible types. So if 2 fails, compile time error will be present. Function overloading, that is method overloading, and constructor overloading is are the examples of compile time polymorphism, because during the compile time itself, the right version to be called invoked is determined. Now have a look into this example. Suppose I have tried some automatic type promotion and exact match between actual and formal parameters, so that you follow easily.
Excuse
Class
me, sir.
overloading is, yes.
Sir, in method overloading, sir, as the function names are same, so what about the memory allocation of those functions, sir? So will it be different
Memory,
or because actually the name of the function is assigned as the variable, the address or no, sir?
yeah. Normally, instance variables are allocated memory every time when the object is created. Methods are placed only once during the running of your program. Methods may occupy right only once, but only thing is this is one version, this is another version. Method takes only one time memory, but here formal parameters are different. Memory is allocated for each of the formal parameters separately or locally.
No, sir, actually in functions, the name of the function will represent the address, no, sir. So
Yes.
if you are using the same name, then the both the address will be different or will be to the same, sir.
Whenever the definition is same, right? Definition, whatever definition is not the same. This version need not be same as that of this version. But if you consider method name is same, in that stage only one memory allocation, but the formal parameters are different. For that we need to have different memory allocation. We need to check it, right? We try to check it with the help of some lang package process, right? We try to check it and then conclude. So as of now, if the two methods are different, no problem. Our two methods are occupying at a different memory locations. Here, of course, a method name is same, but we have an ambiguous situation in terms of parameters. So we need to check and conclude. So better to check and conclude.
Thank you.
Okay, consider this example, class overload EX, void F. This takes only a 0 parameter version. So I have given a message, no parameter version is called. Then void F of int X, one integer parameter version is called and the value of X is printed. F and F of int X, these two versions are said to be overloaded. Then, let me remove this comment. Void F of int X, int Y. A two integer parameters version is called. These three versions are said to be overloaded because they are satisfying the rules of a method overloading. 0 parameter, 1 parameter, 2 parameter. Then 3 integer parameter version. These 4 versions are said to be overloaded. 0, 1, 2, 3. Then these 4 with another version, void F of float X. Right here, F of int X, one integer parameter. Here, one floating point parameter. But the type is different, integer and a floating point. So totally 4 plus 1, 5 versions are overloaded. Then float X, float Y. Already int x comma int y, two parameters, here integer and floating point, different parameter, different types. So these are said to be overloaded. Likewise, a double version, two double parameters up to these. There is no doubt in this. 0, 1, 2, 3, right? Number of parameters and a type of parameters. Based on that, these highlighted versions are said to be overloaded. Next, I have another version, void f of byte x. In this, I have given the message, one byte parameter version is called. The value of x is printed. Of course, it seems that here the method f takes one parameter. Here also the versions f takes one parameter, say integer x, I think one floating point x and a double x. So comparing byte x with int x, float x and double x versions, the type is completely different because here byte is different from int, float and double. Even you can specify long also with one parameter. So anyhow, all these versions are said to be overloaded. Having any queries in this? Because we are satisfying the rules of method overloading. All the versions should have the same name. They should differ, methods should differ only in case of formal parameters. Number of parameters, type of parameters are both a number and a type of parameters. The rules are satisfying. But have a look into this method call statements. This is calling which version?
No parameter
Some
version.
object name return. Okay, no parameter version. This is calling f of 100.
Single parameter.
One integer parameter version. There is no doubt. One integer parameter. So integer parameter is there, right? Even though assuming that one long version is defined, or float version is defined, assuming double version is defined. First, it checks for exact match between actual and formal parameters. So 100 means 100 is matched with this integer version. This version is called. Then 100 comma 200 are two integer versions parameters. This version is called. Having three integer parameters, this version is called. Then this one 125.0 f, one floating point variable. So floating point version is called. Then two floating point variables corresponding to two floating point version, right? This version is called. Then 1000.0, one double variable, double version is there, one double, right? This is called. Then this one double comma double, two double parameters version is there, that version is called. Next, have a look into this statement, some object name, right? Dot method name f of minus 128. Now what will happen? Which version is going to be called? Not get you? What is the problem in this? What is the actual parameter value?
Bytes.
Yeah, byte value, of course. Here is there any byte version? Yes, byte version is there. So what happens? What happens?
Sir, even f of 100 also has a chance of calling the byte version also.
F of 100 also, yes, good.
Sir, ambiguous
F
form.
of 100 also. Ambiguous. What is
Sir,
the
actually,
ambiguity rising here? Yeah, tell me.
Actually, both the times the integer version only will be called, sir.
In both cases, even in minus 128 and 100. Why?
Because actually all the byte variables are type compatible to integer type, no, sir.
Yeah, very good. That is rule number 1. So as we discussed earlier, all byte short, then what one? The corresponding characters are first converted into the integer one. Even minus 128 is same as minus 128 plus 0, right? So minus 128 as a byte value is normally type converted or type promoted to integer value. That's what here given. F of 100 means 100 is calling the integer version. Minus 128 means minus 128 calls the corresponding integer version. Right? So I write here this calls int version. Here also 100 calls int version. What about this one? F of A, what is A? A is a character one. We are passing a character. Is there any character version defined?
Integer.
We do not define a character version, but integer version is there. So using the type promotion rule, character is type converted into integer one. So
Integer.
integer version is called here. Calls int. Then what about this case? A comma I z. Two
Int comma
character
int.
constants we are supplying. And yeah, calls int comma int version.
Double two times.
Then likewise, this calls the
Int comma
statement
int comma
calls
int.
very
Three
good
int.
int comma int version. In case, for example, in this statement, have a look into the statement. This calls int version. Assuming that int version is not given, I commented out this int version, or I check it later. I show you. Okay, next coming to this one. A comma 5.2f. What happens?
Int comma float.
Float goes float, sir.
Int comma character comma float. Character comma float is not available. So character is first type converted to integer one. It checks for integer comma float. Integer comma float version is not available. So integer is further
Float
type
comma float.
promoted to float. So this calls float comma float version. Then in case if I remove this comment, what will happen? Nine point five comma B comma C.
Double version will be called.
Double.
There
This is which version here?
It results in an error. Time error.
It results in an error because compile time error. The version is not overloaded. Double, then write a double char or triple double versions are not defined. So this results in error. Then this one.
Double.
Double comma double. So 9.5 double. Character is type promoted to integer one. That integer is further type promoted to double. So double comma double version is called. First,
Sir,
I show.
excuse me. Sir,
Yeah.
when you're calling A comma Z, sir, then why can't it call that float comma float version, sir?
That's what I wanted to write ask now. Object name dot f of a comma z. This calls int comma int version. Why is it not calling double comma double or long comma long if it is or float comma float?
Sir, already the version is available now, sir. Then what is the need to call other float, comma float, sir? Then
Version is already available. So int comma int version is available. Okay, any other answer?
Sir, by default, characters are type promoted into integers.
Characters are type promoted to integer. Very good. Then any other option? Okay, to answer this, right, or before answering this question, as I said earlier, I try to make a comment on, for example, this version, void f of int x. Let me comment on this version, right? Integer version is commented out. Now, let us check, right, what will be calling for f of a. So, saving the code. How to find it? One, which version? One character version a.
Float.
One float parameter version is called. The value is 97 after minus 128. So this is a minus 128. Here the version called is floating point version. And you guess why floating point version is called? Why not a double version? I am asking you the same question, right? Whatever you ask. Int is commented out, the float is there, even double is there. Why double is not called, or why float is called?
They're actually during the performance of program, sir. If we are accessing more number of, as double occupies more memory, sir, because double occupies 8 bits, whereas int occupies only 4 bits. So for accessing the memory, then it should.
Okay, to answer this question, right, I like to ask one more question. What will happen, right, in case if this is a C++ program? Assuming that here one character version is possible, right? Here, assuming that no character version is there, no integer version is there. In C++, I am asking you, one floating point version is defined and double version is defined. What will happen?
It will show error.
Error. What kind of error? Have you recalled that error?
Type conversion error, I think.
Type conversion error.
compatibility error.
Compatibility error. Have you noticed the words ambiguity between? Am I right? Ambiguity between float and ambiguity between float and double. So the character, right, can be converted into a floating point quantity, and at the same time this can be converted into a double quantity. For example, here are you even assuming that double not possible in C++. So assuming that one integer version and a floating point version is there. So the character can also be converted to integer one, and at the same time character is also converted to a floating point one. So you can see the error message, ambiguity between int and float. Have you noticed those type of error messages?
Yes, sir.
Okay, if not, you need to check it. But in Java, here what happens, based on the automatic type promotion rules, the expressions are evaluated in an order. So first here, if a character version is there, it tries to check for the exact match. Because Java is a strictly typed language, character to character version is checked. If no character version is there, then character is a type promoter to integer one. So that stage it checks for the integer version f of int x. In case if no integer version is there, then the next higher data type a float is checked. Then if no float, right, what will happen is character is a type promoter to double one. So that order, execution order is important. Again, I have a question. Same question I like to ask. In C++, you might have seen that ambiguity between this data type and that data type, say integer and floating point data type. My question is, in what situation we can or the Java compiler raises the same error message, ambiguity between, or in order to have the ambiguity between something error message, what kind of method call should be introduced in this code or in some other code? Understand my question?
Sir, between char and byte, sir.
Between char and byte. Okay, let us check that. Void byte. Void. Let us use one version. Character version. Char x one. Char type parameter version is called. Now have a look into this call statement. Dot f of byte, say minus 127, let us use minus 128, okay, plus 127, then character, exact character, say some s. Do we encounter the ambiguity between error message in this case? Which version will be called when f of 127 is invoked?
Integer version, sir.
Integer version. Because this is not a byte value. Normally byte is type promoter to integer value. So you have to understand that this version will not be called. In case if we have a byte parameter version will never be called during method overloading. Am I right?
Sir, if there is no int version also, won't the byte version will be called, sir?
Yeah, that we need to check it. Suppose int version already commented out, right? If of int x, int version is commented out.
It is converted to float, sir. Float version is called.
That is a question.
The float one also, sir. We'll check.
Ask but one float parameter version is called 127. This one, because integer no type compared no exact match. Then next match is a floating point one. So this calls the floating point version. So we need to conclude right that byte parameter versions will never be invoked. Am I right?
Sir, if there are no int to float double, then won't it call byte even then, sir?
Int, what one?
If there are no int version and even float double versions,
what will happen? That is your
then
question.
even at the time
So
won't it call byte version, sir?
It will not call byte version. That said, what will happen? F of float x is commented out. F of double x is commented out. So all type promoted rules are checked out. Then I can see the error message. This is not possible. So that's what I say.
Sir,
Byte version
sir,
will
when you
never
say
be
that,
called. Yeah, byte
sir,
version
as
will
according
never
to
be
the,
called. Yes.
sir, but according to the rule of Java, as you said, sir, when the actual parameters are passed to the formal parameters, then exact match will be checked, no, sir.
Yeah, exact match is checked.
Then why in this case it is not happening like that, sir?
Exact match means here 127 is, even though a byte value based on type promotion rules, all byte short character or type promoter to integer one. That rule is applicable.
Okay, okay, sir.
Okay, then yes, right, what happened for yes? Previously, right, the character version is called, right, yes. One character, exact match is called. Here also character A, You can look at right the character A. Yeah, here this line. One character parameter version is called A. Character exact match is both. Only when there is no exact match, the extended type promotion rules are applicable. So still, right, we need to answer. Is there any chance to have a byte version to be called? I think no, because bytes or the operands are type promoter to integer one. This version will not be called. Second question.
Sir, but char in
Is
this
there
case,
any
char is not happening.
carries?
Char is not type promoted, no, sir. Because when you are mentioning a character in the actual parameters, then it is invoking the character function only, no, sir.
Yeah, if there is an exact match from character to character, that will be working. But byte to byte is not actually happening. So we have the ambiguous situation, right? You are asking me, right, this group, why including character here in our group? That is your doubt. I accept your doubt. Where is it? Byte short cap. Why did you use here cap? And why we need to use this rule, checking the exact match between actual and the formal parameters? Why there is a separate rule for character and why not a rule for byte, right? That we need to answer. Any other solution? Let us check the type promotion rules again, right? Normally byte short operands are type promoter to integer one. Then when evaluating the expressions, if there is a character plus something, character plus byte or something, the expression is completely evaluated in the integer mode. But here you cannot say this is an expression, character is. This is not an expression. So in this case, right, what happens means compiler tries to check the exact match between actual and formal parameters. Character and the character version is there, so no problem, character version is called. But in the case of byte, right, all byte and short operands are type promoter to integer one. There we
Sir,
included character also. Yeah. Tell
sir,
me.
what if I create a variable of type byte in main function and then pass it into the as a formal parameter, sir? Will that
Byte
get type
variable
promoted
here.
to int or it will stay as byte itself?
A byte will be type promoter to int, right? For example, let us check here. Okay, here. That we need to check. Byte b is equal to 127. Let this be b. Let us check the proof. Which one is called? One byte parameter version is called 127. Good. Because this is a byte type. B byte to byte. Byte version is called. Data type byte. Byte to byte is called. What about ambiguity between two types? Then will we have that kind of error message? Ambiguity between this type and that type.
Sir, if you have both byte and char, what will happen, sir? As
Having both
parameters.
byte and char. Byte parameter takes byte version, character takes character version. That is encoded in this from this example itself. B is byte, so byte version is called.
No, sir, both are together,
Then
sir.
character.
Byte, comma character, like that.
Byte comma character means you try to check the exact match between byte comma char. If byte comma char version is there, then that version will be called. If not, it will be applying the type promotion rules. Byte is further promoted to int. Character is further promoted to int. So check for if int comma int version is there. But even in this example, if we comment on this byte version, let us check what will happen. Last but one, a float parameter version is called 127. What about int? Okay, int is commented rudely. So in this case, a byte, no byte version is there. Byte is type promoted for int1, no int version is there. Then int is further type promoted to double version. So one double parameter version is called. Having any other queries?
Sir, I think we can get ambiguity when we pass 0 as a parameter and when we have the functions like int and boolean, sir.
Int and
Boolean.
boolean. Let us check it. Tell me the parameter versions. Void f. Tell me.
Int x.
Comma. Say
Not
boolean
comma, sir.
b.
Not boolean. Only int x, sir. And another function, it should be of boolean x. That's all. And when you pass the parameter as 0.
Sir, but Boolean will take only if we pass as false only, no, sir, Boolean will take. But 0 means in Boolean we will not get false, no, sir.
Yeah, 1 minute. Int version is already there. Let us have one boolean version. Boolean x one. Boolean parameter is called. Okay, void f boolean. What to pass? The actual parameter. Say one
Sir?
boolean variable, if not type boolean. Say bool is equal to true. B is already declared. Okay. Passing the boolean variable bool. Boolean version is there. So this calls a boolean version. There should be no ambiguous situation. Boolean parameter version is called. Value is true. Since bool is true. So first it tries to check the exact match rate. Byte variable that. If not, a byte is promoted to integer 1. Character variable, actual parameter, it checks for the character type, character to character. If not right, then int. If not float, if not int, if not long, then float double in an order. All are okay based on the automatic type promotion rules. But only thing I have to say, is there any chance in Java to have this error message, ambiguity between two different data types, as we encountered in C++?
So maybe string and character array, sir.
String and character array. I think that will not be the ambiguous message. Time is up anyhow. You try to check and tell me. because character array here actual parameter must be a character array. Array to array, right? There should be a compatibility.
No, sir. If we
In
just
array
enter
can
like if we just enter like hello in will pass a parameter as hello. When we have a character array in string, it will get confused to store whether in character array or string, sir. String type.
okay. Let us check and let us check something, right? The rules. If there is the rule is applicable in Java, or we find out the exact situation where ambiguous error is occurring. Having any other queries? I think I have already asked you one question in the bitwise right shift operator. After some stage, still I remember I asked the question. After some iterations or after some bitwise right shift operation, why that value is changed to 0 or something? I asked the question. You have not yet answered, right? You try to check that also. Plus this one, right? The situation when the ambiguity error between some data type is possible in Java. I shared the code. We will try to go through this. Tomorrow we discuss. Thank you very much.
Thank you, sir.
Thank you, sir.